Bismillahirrahmanirrahim. In this session, I will go through the basic implementation of linear regression, KNN snapper, and decision tree. And for the implementation of linear regression, we will be using diabetes dataset from sklearn library. So let's start with linear regression implementation first. Uh, we will import the necessary libraries first, uh, like NumPy. Then we'll be using pandas for data manipulation. So, and then I'll import and sklearn from sklearn datasets. Import dataset. Then I'll from the linear model, I will import linear regression model from sk one dot linear model. And then for the training and testing purpose, we'll be using a train test split uh, from sklearn at model selection to split the data set between training and testing. And after this, from sklearn.matrix, I will import mean squared error to evaluate the model. Okay, so we are done with importing the basic libraries. So now I'll load the data set from sklearn. First of all, I'll create the variable diabetes. Then from data sets, I'll call load dot diabetes. Okay, so here you can print this just to see what's in this data set. So it will take a little bit time because it is not connected to the runtime. Okay, here we can see the data set. Now, after this, I'll convert this diabetes data set to the pandas data frame. So let's initialize variable. I call diabetes here, and then I'll convert this into data frame with the feature data and the feature name. We can use this code, and then I'll add that also add the target data to the data frame as well, and that which is diabetes here. Target. Okay. Perfect. So the next step is to check the data set first 5 rows. For that, we can use dataset dot head. Okay. So now let's run this code. So here you can see we have input variable like age, sex, then BMI, BP, blood pressure, and then S1, S2, S3, S4, S5. These all are the input variables. And Then in target variable, we have continuous values. So these are all input variables, and the target here target is the output variable. So the next step is I'll select the input features and the output feature. So from the input features, I'll drop the target variable because for the input we don't need target variable, and for the output we'll be having only a target variable which is in y. So uh, let me just print the first x and y, and then print y. Okay, let's see. Oh, so you can see that in x we have input variable age, sex, BMI, and S6. So then in output we have only one variable which is target, and which has continuous values. Okay. The next step is to split the data into training and testing set with I'll go with test size of 20 and then training of 80%. So for that you can use okay. Okay, now in X train I will be having training data, and X test I'll be having testing data, and similarly for in Y train Y test I'll be having training target, and in Y test we'll be having testing target. So basically to this function we pass three main attributes like training input feature, and then we pass the target feature, and we specify the train test split. Here 0.2 means we will be having 80% data for training, and then the 20% for the testing purposes. Okay. And so the next step is to create the linear regression object. So I will create the object of linear regression. And the next step is to train the model using the training set. For that, we can use the regression dot fit function, and to this function, we'll pass the input variables and the target variable. So use this X train, and then one more variable Y train. Okay, so I'll run this code and let's see what happens. Actually, until here we are done with the training part. So the next is to make prediction on the testing data set. So Uh, I'll create variable y prediction and then regression dot predict. And to this function, I will pass the testing data set. Perfect. So let me just print this by prediction. Okay, now you can see the predictions array. And now the next step is to mm, evaluate the model performances using mean squared error. So mean squared error, I from the function mean squared. To this function, I will pass to the actual testing data and then the prediction. Okay. And then I'll print the MSC. Okay, perfect. Here you can also print the Y prediction array and also you can print Y test, which is actual output to see the difference between prediction and the actual data set. So here we have actual values, so predictions, and then here we have the actual data set values. So we are done with the implementation of linear regression. Now I'll move towards the implementation of k-nearest neighbor. First of all, I'll import the basic libraries like pandas, then from sklearn, I'll import datasets. Okay, and from sklearn.neighbor, I will import the k-nearest neighbor classifier. Then for training and testing, for training testing speed, I will import from sklearn dot model selection. I will import train test split, and then for evaluation purpose, I'll be using a accuracy score. So we are done with importing basic library. So for the KNN implementation, I'll be using iris dataset. So let's create variable iris and then load the data set. From data sets dot load iris. Okay, perfect. And the next step is create a data frame with the feature data and feature names. So I'll convert this into pandas data frame. And let's call it called iris here. And then I'll add the target variable to the iris uh, iris data frame, and then we print the head of data set. So let's run this code first. Okay, here we can set, we can see the head of data set. In input, we have four variables: simple length, simple width, beta length, and beta width. And for target, we have classification like 0 and 1. And the next step is to split the data set between training and testing. So let's train. So here we'll be having 80% data for training purposes and the 20% for testing. Okay, the next step is to create KNN model. KNN and KNN classifier, and here I will pass the value of k. So let's suppose I give the value p. And then the next step is the training the model. For that, I'll use knn.fit, and here I'll pass two variable xtrain and then ytrain. So if once we are done with training part, then the next part is prediction. So y predictor, I knn dot predictor, and to this function I'll pass x test. Okay. So let's run this code to see what happens. Okay. And we print this predictions, print y predictions, and then print actual values. So here you can see the predicted and actual values. Sorry, I don't. Uh, I think we forget to here give the value to x and y. So let me just do that. So in input feature, we'll give the four values: petal length, petal width, and sepal length, length and width to x, and then target variable to y. So let's run this code again. Okay. So here you can see the actual values and then predicted values. So the next step is to evaluate the model performance. For that, we'll be using accuracy score, accuracy, accuracy score, word test, and then Y prediction. And then let me create this accuracy. So where we have one, which means that we have 100% accuracy for KNN classifier on the ARIS data set. So we are done with the implementation of K-nearest neighbor. Now I'll go through the implementation of decision tree. For decision tree, we will be using the same iris data set. So we don't need to write this code. So I'll just copy from here and then we'll paste. Okay. We just need to change one thing here. For decision tree, we will use sklearn dot tree and then I'll import decision tree classifier. Okay, perfect. And the next step is to create the decision tree model. So I'll initialize variable decision tree and then decision tree classifier. Okay. Here we have initialized the decision tree model. The next step is to train this model. Train, as we already know that we can use the fit function, and to the fit function we pass two things: the training data, input feature, and then output. Okay. Then the next step is to make prediction. So by predict, you dt dot predict, and here I'll pass x test. So let me just print this. Y prediction mean the prediction of the model and the actual output. Let me just run this first and then we'll go towards accuracy. So here you can see the actual values and predicted values, and then the next step is to calculate the accuracy model. For that, from the accuracy score, we can use y test and y prediction. Okay. Accuracy. So here you can see we for CN3 implementation we have 100% accuracy. The one thing that need to tell is that you can change here the training testing split. Mean if you do here 0.3, then you will be having 70% data for training and 30% for testing purpose. And similarly, you can change the random state as well. So you can give the value 32 random state and print the value, print the accuracy. Now here, one thing note is that we'll be having more data in testing. Firstly, we had 20% for training and testing and 80% for training. Now we have 70% data for training and then the 30% for testing. Okay, so we are done with the implementation of linear regression and decision tree classifier and KNN classifier. I hope you found this tutorial helpful, and thank you for watching. Allah Hafiz.